In this lesson, you will be introduced to what we call polynomials. Specifically, you will learn how to add and subtract polynomials. Let's take a look at some notes and examples that further explain this concept. If you look at these two polynomials, you will notice that they are simply a string of terms put together by plus and minus signs. Each of these is called a term. So in this particular problem, there are 4 terms. If you look below at the green polynomial, there's 1, 2, 3, 4 terms. When you're dealing with polynomials, you want to make sure that you write them in what we call standard form. Standard form is determined when you write the terms in order from highest exponent of the variable to the lowest exponent of the variable. So let's take a look at these two problems again, but this time we're going to rearrange them so they are in standard form. For the first polynomial, if you look at the 4 terms, you must first decide which term has a variable with the largest exponent. And hopefully you can see that it's the negative 2x cubed. So you want to move that to the front. Then if you look at the remaining terms, the term with the next largest exponent is the negative 3x squared, because 2 would be the next largest compared to the 3, which is the exponent of the x in the first term. So let's move the 4x back and slide the negative 3x squared over. So notice right now, just focusing on the exponents, 3 is the largest, then 2. So now we're going to move it down to the next one. The next term, we have either 7 or 4x. Because 7 does not have a variable, we will automatically place the 4x after the 3x squared. Now, we must have a sign, either plus or minus, between the terms. Because the 4x is positive, we will place a plus sign after the 3x squared. This leaves the positive 7 at the end. 7 is called a constant because it does not contain a variable. So we now have reorganized this polynomial and put it in standard form based on the exponents of the variables. The third term, the 4x, if you notice, you do not see the exponent, but in fact it has an invisible 1. So now you can see that the exponents go from 3 to 2 to 1 to our constant. Let's try the same thing with our second polynomial. Which of the terms, the negative x squared, the 5, the 9x, or the negative 2x cubed would come first? Hopefully you can see that it's the negative 2x cubed because its exponent is the largest. What would come next? The negative x squared, and it's already in the correct place because its exponent is 2. So now we have 3, 2. So now we're looking for the next term with an exponent of 1 for its variable. And recall that 5 is a constant because it has no variable, so it will go at the end of our polynomial. Now we have reorganized our terms in this polynomial and put them in standard form. The next thing you will want to understand is the words monomial, binomial, trinomial, and polynomial. The word mono means 1. So any polynomial with 1 term would be considered a monomial. So if you look at all these different polynomials in black, we were going to drag each one of them that's only 1 term into the circle marked monomial. So we have the 3. That's considered a polynomial, a type, but more specifically a monomial. The 6x squared, and we know that is a monomial because it doesn't have any other terms added to or subtracted from itself. The negative 5x is also a monomial. So those are our 3 examples of monomials. The binomial, bi means 2. So we want to pull in any polynomials with two terms. So we can pull in the 4x squared plus 8, because those are just two terms, and the 2x minus 1. From there, we'll move to trinomials, and the word tri means 3. So we're going to pull in any polynomials with 3 terms. So we have 1 and 2. The last circle, which is simply polynomial, any polynomial with more than 3 terms does not have a special name, so we will just throw in the remaining polynomials that have 4 terms. However, all of these are considered polynomials. It's just we want to specifically group them by the number of terms, so anything larger than 3 we just call a polynomial. Let's take a look at our next page. Here it says gather the like terms and combine. So we've talked about terms, but now we're extending it to like terms. So like terms means if you have, for example, in our green polynomial, we have 4 terms. You want to identify the terms based on their variables. So if you look at these 4 terms, you want to identify, first of all, the terms that would be first if you wrote it in standard form, which means focusing on the x only because it's the first variable, look at the exponents. And notice both the 3x squared y and the negative 2x squared y have a 2 for the exponent. So those would come first. Now because their variables match, we can actually combine them together by adding or subtracting what's called the coefficients or the front number of the terms. So we have a 3 and a negative 2, which means we will subtract. It's like saying 3 plus negative 2 or 3 minus 2, which leaves us with 1 x squared y. So the variables and exponents do not change. We're simply combining them together using their coefficients or front terms, or front numbers, excuse me. Then if you look at the 4xy and the 7xy, their variables match as well. Not only do their variables need to match, but the exponents of their variables as well. So to combine them together, we will simply add the front numbers 4 plus 7, which would give us a positive 11xy. Now, of course, when we write our answer, we do not need to write the 1 in front of the x squared y. So the best way to write the answer is x squared y plus 11xy. In the next polynomial, again, you're going to look for like terms to combine together, but you're going to start by focusing on the exponents of the x's. So as you're combining things, you're writing it in standard form. So 3 is our largest exponent, and you can see we have another term with a 3. So we're going to combine those two together. In the first term, recall that if you do not see a number in front of the x cubed, it's a negative 1. So what we're actually combining is we're combining negative 1 plus negative 2, which makes negative 3x cubed. And often what I do is I will cross out the terms after I've combined them so that I can see exactly what I have left. The next terms we'd want to focus on are the ones with the exponent of 2. Again, in this second one, we need to put a negative 1, and we're going to add a negative 6 and a negative 1 together, which would be negative 7, but we keep our variable and exponent the same. After this, we would move to the terms that have an exponent of 1, which would be the 9x and the negative 7x. So adding together the positive 9 and the negative 7, we would get a positive 2x. Lastly, we can focus on our constants, which are 5 and 6. And just like the others, they are considered like terms, so we'll simply combine them together, leaving us with a final constant of 11. So we've done two things here. We've both combined our like terms by adding the coefficients, as well as put our answer in standard form as we go. Let's take a look at some further details about what you've learned. So some of the things that we've already gone over as you look at these notes. We've learned that mono means 1, bi means 2, tri means 3, and poly means 1 or more. Okay, some of the other things, the word term. Term is an expression separated by a plus or a minus sign. And it shows you here that for 3x plus 2, 3x is a term and 2 is a term because those are separated by that plus sign. A monomial is an expression with only one term, like 3x. A binomial is an expression with two terms, like 3x plus 2. Here's our two terms. A trinomial is an expression with three terms. As you can see, we have x squared, negative 4x, and 3. And then let's scroll down below so we can talk more about a polynomial and look at further examples. A polynomial is any expression, no matter how many terms. This is the big name for every expression, no matter if it has one term or 10. The word coefficient I mentioned several times, and this is the number in front of the variables. So for example, in the polynomial 3x, the 3 is the coefficient. For a constant, as we talked about, is any term in a polynomial that has no variable. So in 3x plus 2, the 2 is the constant. Now let's look below at this polynomial. X squared minus 2 plus 4x minus 2x to the fourth plus 3x cubed. There are three things we're going to do with this polynomial. Number one, we're going to identify the terms, which you can see I've done in red. So I've just simply separated each of the terms out. So you can see that there are 5 terms. Then, secondly, we're going to identify the coefficients. So the coefficients of each term is simply the numbers in front of the variables. So the constant we can exclude from this because it doesn't have a variable. So for x squared, the coefficient is 1, which we have right here. For 4x, the coefficient is 4. For negative 2x to the fourth, the coefficient is negative 2. And for 3x cubed, the coefficient is 3. The third thing it says to do is identify the constant, which we know is negative 2, because that is the one term without a variable. Let's now take a look at some further information on standard form. Okay, recall that standard form is simply rearranging the terms with the largest exponent first down to the smallest and having the constant always last. So just to show you two additional examples, we have x squared minus 2 plus 4x minus 2x to the fourth plus 3x cubed. So if you look at those terms, hopefully you now understand that negative 2x to the fourth would be at the beginning of the polynomial in standard form. From there, we would move to 3x cubed because it has the second largest exponent. Then x squared, then 4x because its exponent is 1, and then our constant at the end. The same is done in our second example. So in this problem, the 8x to the 6 comes first, negative x cubed second, because cubed comes next after 6, negative 5x squared, the 2x to the first, and then our constant at the end. Now let's take a look at how we might add and subtract polynomials. Before we actually add and subtract, we need some additional understanding about polynomials. One thing we want to understand is what the word degree means when we're talking about the degree of a polynomial. And it's very simple. It's simply the largest exponent. So if you look at this first polynomial, 3x minus 7, we say it is a first degree polynomial because its largest exponent is 1. In the second polynomial, we call this a second degree polynomial because its largest exponent is 2. In this next example, the largest exponent is 3, so we call this a third degree polynomial. So the degree is very simple. It's simply identifying the largest exponent of the polynomial, and that becomes its degree. Now let's take a look more specifically at the adding and subtracting by reviewing again some like terms. So remember, like terms are terms that have the same variables with the same exponents. So if you look at this problem, we're actually going to be adding three different polynomials. Here we have a binomial plus a binomial plus a trinomial. And we want to look for the terms that are like terms and combine them together. So again, we're going to start with the term with the highest exponent. So as we're going, we're putting it in standard form. So our negative 5x cubed would come first. And notice no other terms have an x cubed in it. So we will simply write the negative 5x cubed and leave it as is. Let me cross it out just to remember that I've already used it. Looking at the remaining terms, you can see that the next largest exponent are the terms with the x squared. Now let's put a 1 in front of the plain x squared so that we remember when we combine them together, we're going to add the 1 and the 8, which gives us 9x squared. We will then cross those out and move to the terms that have an exponent of 1, which would include the 3x, the 4x, and the negative 1x. In this case, we would add all three coefficients together, 3 plus 4, and then subtract 1, which leaves us with a positive 6x. Finally, we look for any constants. In this case, there's only one, and that would be our negative 7. So notice we've combined all like terms as well as written our answer in standard form. Let's go look at some additional examples of adding and subtracting polynomial. In number 3, we have a trinomial, and we're just simply going to look if there's anything further in this trinomial that we can combine. So to do this, we need to look at the variables only, as well as the exponents, and see if any of them match. Our first term has an x squared y cubed. Our second term also has an x squared y cubed, as well as our third, which means all three of these terms are like terms and can be combined together. The x squared y cubed will remain the same. Again, all we're going to do when we combine like terms is add the coefficients. So we're adding 3 plus 8 and then subtracting 5. So that would give us 11 minus 5, or 6. So our answer would be 6x squared y cubed. Number 4 is similar to number 3, except for we have a trinomial being added to a binomial. So again, we're going to start, and this time, because it has a variety of variables, we're going to put them in alphabetical order, which is how we would put them in standard form. So when you have multiple variables like this, always start with the letter that comes first in the alphabet. So if we combine the negative 4 and the 3, so negative 4 plus 3, we would get a negative 1a, which is the same as negative a. We would then move to the terms that have the b and add their coefficients, so 3 plus 4, giving us, let me just change that real quick. The 3b is the only term that has a b, so that will simply drop down into our answer. We will then move to the terms that have c's, so 5c and 4c, and add their coefficients, which would be 9c. So this would be our final answer in standard form. Let's take a look at some additional examples. Number 5 can be tricky because notice in this problem there's a minus sign between the parentheses. In this case, we are actually subtracting, not adding, the like terms. So in this case, what we must do, because the minus sign is in front of the parentheses, it's like a negative 1. So we can't do anything with the first trinomial until we've distributed the negative 1 to every term in the second parentheses. So what you may want to do is drop down your first trinomial and then go ahead and distribute the negative 1 to the coefficients of each of the terms in the second parentheses. So negative 1 times 3x cubed would be negative 3x cubed. Negative 1 times 5x squared would be negative 5x squared. Negative 1 times negative 5x would be positive 5x. And negative 1 times negative 1 is positive 1. So now it looks like we just have a big string of terms rather than two separate polynomials. So from here, you do what we've done in previous problems. You combine the like terms, starting with the exponent that would come first in standard form. So this would be the x cubed and the negative 3x cubed because its exponent is the largest. So if we combine those, we have a 1 and a negative 3. Adding those together, we get negative 2x cubed. From there, we'll move to the negative 3x squared and negative 5x squared. Adding their coefficients together, negative 3 plus negative 5 is negative 8x squared. We then have negative x and 5x, or negative 1x and 5x. So negative 1 plus 5 is positive 4x. And then our constant will be at the ends. Notice in problem 6 that in each case we've got a number in front of parentheses for the first set as well as the second. So we must distribute the number before we can combine like terms. So we would get for the first set of parentheses 6x squared plus 2x plus 10. In the second set of parentheses, if we multiply each coefficient by 4, we get negative 4x squared. Now be careful right here, the negative 4, when you multiply it by the negative 2, is a positive 8x. That's probably one of the biggest mistakes that we've seen. And then we'll multiply the negative 4 and the 3 to get a negative 12. Once we've distributed and the parentheses have been removed, we can combine like terms. So again, we will start with the terms that have the largest exponent for the x's. So adding their coefficients, 6 and negative 4, we get a positive 2x squared. From there, adding 2x and 8x, we get positive 10x. And then lastly, adding our constants together, we will get a negative 2. Let's look at one additional example of adding and subtracting polynomials. In this last example, notice the way that the problem is stated. It says, if f of x equals 3x minus 5, so f of x is simply a way that we write function, which is the same thing as if I would have written a y. And g of x equals 2x plus 7, find f of x plus g of x. So all you're doing is, because f of x is equal to this, you can replace the f of x with 3x minus 5. Then we're going to put a plus sign in between our polynomials. And then because g of x is equal to 2x plus 7, the little g of x symbol can be replaced with 2x plus 7. So now it just looks like any problem we've done in the past. So now we will simply combine like terms. Because we have a plus sign in front of the second parentheses, there's no need to distribute anything. We can simply ignore the parentheses and combine like terms. Starting with our 3x and 2x, if we add their coefficients, it would simply be 5x. If we then add negative 5 and 7, we'll get a positive 2. And those cannot be combined because those are not like terms. 5x plus 2 would be the final answer. In problem B, notice two things. First of all, g of x and the f of x have been switched. And secondly, there's a minus sign. So just be careful in the order in which you write the polynomials and make sure a minus sign is in front of that second set of parentheses. So first replace the polynomial that represents g of x, which is the 2x plus 7. Drop down your minus sign. Then replace the binomial that represents f of x, which is 3x minus 5. Now we're going to put a negative 1 in front of that second set of parentheses and distribute it or multiply it to each term in the parentheses. So drop down the 2x plus 7. And once we multiply the negative 1, it'll be negative 3x. And then again, the negative 1 times the negative 5 is a positive 5. From here, we can combine like terms. So if we were to add the 2 and the negative 3 together, we get a negative 1x, or negative x. When we add our constants, we get 12. So our final answer in standard form is negative x plus 12. And that completes the lesson on adding and subtracting polynomials.